Okay, so another one on constitutional isomers, and this one I chose because this is a killer one, okay, and this one pretty much encompasses what it means to have constitutional isomers. So I chose C5H10O, okay, and so in this case we have an oxygen. So we do the same thing as before. We have C and H2N as our key to get started. And so this is C5H10, and that is an alkene formula. And you also have an oxygen. When you have an oxygen, that just fits in, okay? So it doesn't replace any hydrogen or anything like that. So it can just fit in, and so it's not usually part of the formula. So it's fine, okay? And so you don't add or subtract any hydrogens for that. Okay, so we have an alkene. Alkenes mean we have either an alkene, which means a double bond, or we can have a ring, okay? The double bond here can be of different kinds, all right? There can be two kinds. There can be a carbon-carbon double bond or a carbon-oxygen double bond, because we also have an oxygen present here, okay? So you can have two kinds of double bonds here. So that's kind of what we're working with, so which means that we'll have to be extremely systematic with what we do, okay, in our structures. So let's go ahead and get started. The first one we'll take is an alcohol plus an alkene. If you're not systematic in this one, then you will really lose track of what you're doing, okay? So let's go ahead and get started. 5 carbons, so 1, 2, 3, 4, 5. And then here is your OH. You can draw the double bond here, but it's not a good idea because this is actually a resonance structure of, not resonance structure, it's kind of a resonance structure, yes, for an aldehyde. So it's not the best way to get started, all right? So what you should get started with is actually, or what you should draw is a double bond 1 carbon away from the alcohol. Okay, so this one, 1, 2, 3, 4, 5. Okay, and now we can move the double bond around, and so we have OH here, move the double bond here, and then we can move it once more. 1, 2, 3, 4, 5, right here. Okay, so we have our 3 double bonds, and then we can go ahead and move the alcohol. So move one thing at a time, don't move everything, okay, at the same time. So we're going to start with the first one here, number it 1, 2, 3. Okay, so I'm going to take number 1. So 1, 2, 3, 4, 5, and my double bond was in this location. I'm not going to put my alcohol where the double bonds are, okay, so which means I'm going to take it 1 carbon away. All right, so that's what I'm going to draw. And then I'll try and move it once more. So here is my double bond, and then here is my alcohol. So now when I look at this structure, and I look at structure number 2, those two are the same. Okay, so you have to watch out for that, which means I have 4. And 5 really is not really 5. Okay, all right. So now that I have moved that one, I can try from number 3 and see how that works out. So again, 5 carbons, 1, 2, 3, 4, 5, double bond over here. Alcohol was at the end, and now I can move that here, and that is fine. I can try one more. Here is that, and here is my alcohol. And I think I'm still doing okay. Yep, because the alkene is a terminal alkene, okay, which means on the end. So we're doing fine, which means now I have my 5th and my 6th. So this was all just double bonds and alcohols moving around. Now I can start moving my carbons around, and you can imagine what a mess this is going to become, okay? But let's go ahead and try a few of these out. I'm not going to draw all of them, because that really will be quite a mess. Okay, so if I'm moving a carbon, I have to draw a chain of 4 carbons. Okay, so 1, 2, 3, 4, and then here is my OH. I have to have a double bond, and here is my methyl group, okay, that I moved. And then I can move it once more. So 1, 2, 3, 4, and then alcohol, double bond, and then here is my methyl group. Okay, so there is one. I can also put the double bond on the terminal carbon. So 4, 1, 2, 3, 4, OH, and then I can move the methyl group here. And one more. I think I can manage this one. Maybe I could manage one more for this one. Let's see. OH there and that. Maybe. But no. This one resembles structure number 5. Okay, so I can't have that. That's a duplicate. All right, so that's out. So I have 7, 8, 9, 10. Okay, now I can try moving 2 carbons if I want to. That's going to be a little bit challenging. So, which means my base should be 3 carbons. I have to have a double bond somewhere. And then I have to have an alcohol somewhere. So let's go ahead and do that. And let's see if I can move 2 carbons, which means can I do this one and that one? Is that possible? And I have 1, 2, 3, 4. That's my longest chain. It means that I have probably drawn this before somewhere, because I've had a 4 carbon chain before. 1, 2, 3, 4. 1, 2, 3, 4. Nope. 1, 2, 3, 4. Okay, it seems we have a new one. Okay, I'm going to write it for now. Then we'll check the name later on. Okay, at some point. All right, or maybe you can see if they're the same or not. Okay, that was just alcohols and alkene. Now I'm going to go on to a cyclo alkane plus alcohol. You can see I'm running out of space already. And I'm going to try and do the small here, starting with 5-membered alcohol right here. That's the only one I can draw. Going on to 4. So I have to have a methyl group, and I can have more of this one because, oops, I can move that one, and then I can move it once more to give me another one. And then I can go ahead and draw my cyclopropane, a 3-carbon structure. So now I have to have 1, 2, 3, 4, 5. Okay, and so I can draw, I think, let me see, and then I think I can have one more. There. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 isomers. Okay, over here. And then I can go on to my aldehydes and ketones, because aldehydes and ketones are the ones that have the carbon double bond oxygen. Okay, so start with 1, which means let's start with aldehyde. 1, 2, 3, 1, 2, 3, 4, 5. Aldehydes are terminal groups. Okay, so you have to have 1 double bond. And here is my double bond. So if you want to kind of count your hydrogens for once at least, it's a good idea. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so which means we're fine with our counting. So now we'll go ahead and move the carbon, because this is the only straight chain we can have. So which means I have to have 4 in a chain. So 1, 2, 3, 4, and then draw the aldehyde. 1 carbon, and then shift that carbon once more. 1, 2, 3, 4, and then move it here. Okay, and then we can move 1 more carbon. 1, 2, 3, and move 2 carbons. There you go. Those are all the aldehydes that we can have. And then the ketones, again, 5 carbon structures. So let's start with, remember ketones have to be in the middle, okay? They're not going to be terminal. So 1, 2, 3, 4, 1, 2, 3, 4, 5, and ketones are in the middle. And count the hydrogens again if you want. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're still doing fine. Move the ketone one time. And then we have to move carbons now. So we'll take the first structure and draw only 4 carbons. So 1, 2, 3, 4, and then move 1 of the carbons over here. So that's what we have. So we have 4 aldehydes, and we have 3 ketones. All right. So that is a whole bunch of constitutional isomers for just one formula. Okay. So this goes to show you that it's not easy, okay, to do all of this constitutional isomer business. But anyhow, you can have many, many structures.